by the one tutorial today. So, the tutorial is basically on the methodology related to the gas chromatography and mass spectrometry. So, basic things which are the principles related to this particular machine will be just spread here, and after that you will go into the laboratory where you will see that how this machine works. So, first we have that what are the chromatography, that it is basically a Greek chroma meaning color and graphene meaning that is the writing. Then we have the chromatography is basically a way to separate different parts of a mixture on the basis of their what are the factors that is responsible. One is that the charge, then shape and size, polarity, and that the affinity. So, actually it was earlier planned that the GCMS was described by the Professor Andreas Bajgos, but he told that the machine he was using is different than we have the machine. So, that is why I am just giving the basic idea about this lecture. Okay. So, we have a Russian botanist that Mikhail Tush in 1903 who has developed the chromatography itself. Then these are the some of the basic principle of the chromatography, that what are the things are under this, that the chromatography works based on the concept of the distribution coefficient that is known as a KD, which explains how a substance that called to analyte is spread between two different phases, that is the stationary phase as well as that of the mobile phase. These two phases can be a liquid, solid or gases that don't mix, and the KD values tell us how much of the substance goes into the each phase. It might be a stationary phase, it might be a mobile phase. So, the higher the KD, that is the coefficient distribution, the more substance will stay in that particular phase and the other. We have two phases that I have already told, stationary and the mobile. This phase is basically stay in place like a solid or liquid that is fixed at one place. Then mobile, this is the phase that moves like a gas or liquid which carries the analyst for the stationary phase. Just have a look at how the first chromatography experiment was conducted by the Toesch. He has just taken the leaf, macerate it, and then have a liquid, that is the sample pigment are there. Here it is the first, that this is your gas column, and on this side the mobile phase, or you can say the liquid phase. In between these we have, that is the calcium carbonate bead. These are the calcium carbonate bead, which is basically a stationary phase, and they cannot move from one place to the other place. So, after going through these things has been separated, that is the chlorophyll A, B, keratinite and xanthophyll. In my opinion, this experiment is already you people have done in the BSc third semester plant physiology experiment in the Aligarh Muslim University, Aligarh itself. So, here we have a sample analyte, that how this is going to be interact. It is a mobile phase, there is solid or liquid. These are some of the phases. What are the possibilities in the chromatography is basically that it may be solid liquid and solid liquid, liquid gas or liquid gas. So, stationary phase may be the solid liquid and the mobile phase varies as. So, these are the three possibilities that can be generated in the particular. We have then the gas chromatography and mass spectrometry. Here in gas chromatography, the mobile phase is basically a carrier gas, and the stationary phase is a solid or the liquid. This is the basic thing. And in the GC, it is basically it is a technique that used to separate and analyze the volatile compounds And what are the types of GC? That gas solid chromatography, it was earlier used where analytes adsorb onto the solid phase, and then we have a gas liquid chromatography where analytes partition between a liquid and gaseous phases are to be separated. Then we have the mobile phase. The mobile phase in gas chromatography is basically a carrier, and it might be a helium, nitrogen, argon, or the hydrogen. These are the some of the gases which has been used as a mobile phase which transport the analyte through the system. Then we have the stationary phase, that is in the GSC. The stationary phase is basically a solid absorbent, whereas in GLC it is a liquid coating on an inert solid. Then what are the separation principle, on what basis it has been separated? That the compound separate based on their interaction with the stationary phase and their boiling points. Whatever the boiling point, it may be high or low, on that basis it has been separated. Then we have a carrier gas requirement. What is that? It must be dry, oxygen free, and chemically inert to avoid unwanted reaction with the analytes. This is the, then what are the basic component of the GC we have? That one is the carrier gas controller that regulates the gas flow. Then we have an injection port, okay. Then column, detector, and data processor. These are the component of the GC system. Then अभी आप जब जाएंगे वहाँ मशीन देखेंगे तब आपको ये सारी चीज़ें समझ में आ जाएगी मशीन में एक आपको वो करके दिखाया जाएगा. Then we have a sample injection. It may be liquid or solid or vaporized in heat. Then GC column, that is the packed column, capillary column. Then we have a temperature control, that it might be different parts, injection port, column, detector. All three are maintained at a particular specific temperature to optimize the separation of that material. Then we have a detection method, that common detectors include flame ionization detector, thermal conductivity detector, and mass spectrometer. Then we have a detection method. So what are the application and advantages are basically for this GCMS is that it is used in food analysis, forensic science, environmental testing, pharmaceutical industries to identify and quantify volatile compounds. In our case, the plant hormone can be analyzed by this particular hormone. Okay? Then what are the advantages we have? That the GC offers high sensitivity, fast analysis, and excellent separation for volatile and thermally stable compounds. Okay. Then application of the sample, आप जो sample देंगे उसका इसके लिए कैसे apply करेंगे? Then that we have the non-polar and low polar compound are easy to analyze. This is the first point. But polar compound may have issues with excessive retention time, poor resolution, and peak tailing. This is the main thing. Then we have a derivatization method like methylation, salinization can help to improve polarity, distribution coefficient, making polar compounds more suitable for GC analysis. So why polar compound is suitable? Only due to that reason जो है. The sample is dissolved in solvent. अब आपका sample है किस में dissolve करेंगे? So that is your acetone, heptane, or methanol avoiding chlorinated solvent due to the contamination risk. So these are the some of the other points. This is the working of the GC. We have this is the basically the vacuum function maintains low pressure, then enhanced sensitivity and the optimized pathway. Just here injector, that how we are going to inject that particular region where the sample is introduced in the GC system, and then it is heated to vaporize the sample and inject it into the column for separation. Then this is the basically the column, long tube inside the GC, inside this type of the column where the sample separate itself, and the stationary phase inside the column interact differently with the different components. This is the just we have open it here, it will not be open in there. So the oven maintains the control temperature for the column. It can be programmed to increase the temperature. जो उसका प्रोग्राम है कंप्यूटर के थ्रू, उसके थ्रू हम कर सकते हैं. Then we have launched the detector, the mass spectrometer detector identify and quantify the component separated by the column itself. Just data system software we have. So whatever the peak we will get a particular data from that particular system. The data system basically records whatever the output from the detector that processing the chromatogram and mass spectra for the analysis itself. It provides information to help identify the component of the sample itself. Okay. This type of the peak we are just having, it might be a peak representation, it is the comparison of the group we can, it's particular one group, two group, three and different. Then the toxicity impact we may also have identified, then a particular compound that specific retention time that might be 299, 174 are likely to be associated with the identification of compound of each group. So each particular group have a particular retention time on the basis of which a particular hormone or particular compound can be identified very, very easily, and the GCMS analysis that use of gas chromatography, mass spectrometry basically allows for precise identification and quantification of our compound with peak areas correlating to the concentration of the each compound. So finally, we have a conclusion that what we will do after going through the GCMS itself, that a powerful analytic tool, it has a metabolic profiling as well as the toxicology and plant health, and their future application is that this particular technique has a vast potential in our plant biochemistry, aiding in crop improvement, sustainable agriculture and environmental monitoring. So this is the basic thing, and now we by a member of 10 member from this from here to move into the our instrumentation room, where our technical assistant is there, and he will give you an idea that how this particular instrument will work. Okay? तो वहां पे जाएगा, हैं? रिकॉर्डिंग खाली कर लो, थोड़े से करके रिकॉर्ड कर लो, है? So okay, just to go 10 people, first two line.